Welcome to the class. In this first chapter, we're going to look at three great cosmological revolutions in our understanding of the universe. So people used to think that the Earth was the center of the universe and that everything revolved around the Earth, which seemed obvious since that's the way things appeared. But in the 16th and 17th centuries, scientists figured out that the sun is the center of the universe, which is called the heliocentric solar system. And then in the 19th and 20th centuries, scientists figured out that we lived in a disk-shaped Milky Way galaxy and that there's trillions of galaxies in the universe. And finally, in the 20th century, scientists realized that the universe began from a small point and expanded ever since then. And then you might consider dark matter and dark energy, the discovery of those, revolution, since that's 95% of what the universe is. So first we have the heliocentric solar system, and Copernicus first observed the rotations of the planets around the sun. Galileo observed with his telescope things like the phases of Venus, and then Newton proved that gravity causes the planets to orbit around the sun. So in case you've forgotten, there's four interterrestrial planets: Mercury, Venus, Earth and the Moon, and Mars. Then there's four gas water giants: Jupiter, Saturn, Neptune, Uranus, and then there's Pluto, which is no longer a planet. And this picture is a little deceiving because the planets are very small and very widely spaced, not relatively big and close together. Then here's the Milky Way galaxy. It's shaped like a disk and has arms. And here's where the sun is in the Milky Way galaxy. And you can see that this little circle is the area where we can see planets or detect planets orbiting other stars. We can see far out into the universe, but as far as finding planets, it's just in this little neighborhood here in the Milky Way galaxy. And finally, we have the Big Bang model, and this is not meant to be the shape of the universe, but it's a timeline going this way, and then this is sort of the volume or the length scale of the universe. But you can see that scientists have figured out that there was a period of huge inflation at the beginning, then there was a dark period with no stars, and then the first stars formed, and gradually they became galaxies, and around here, that's when the sun formed, and then ever since then we have the Earth and sun, life on the Earth, and so on. So scientists first figured out that the universe was expanding based on the redshift of light. We'll talk about that in this chapter. The general theory of relativity is the equation of the universe, and Lemaitre applied that to the expansion of the universe and found that it all made sense. And so we'll look at Lemaitre, look at the use of that equation. I'd like you to watch this video from National Geographic. It's embedded in this section. Actually, we could watch a minute of it or two now.
There are powerful forces at work in the universe. But what's amazing is that in the entire universe, nothing is more powerful than the colossal explosion that created it all, the Big Bang.
The Big Bang is an amazingly difficult thing to wrap your brain around, which isn't surprising. When you're trying to think about the universe being smaller than the head of a pin,
Actually, smaller than an atom, about as small as the proton at the center of an atom. Whatever the universe was at the very beginning, some 13.7 billion years ago, we think it was tiny, an infinitesimal nugget of space. And then something happened, triggering the most colossal explosion in history. In a billion...
Okay, so you can watch the rest of that video. It's embedded in this section of the HTML page. And like I said, dark matter and dark energy are 95% of the universe. And so that was somewhat of a revolution, knowing that what we can see, the stars, gas, and planets that we can see, is only 5% of the universe. And most of it is the stuff we can't see, but we know about it from the rotation rates of galaxies And then dark energy is another thing that we found out about, and we've known about that from the expansion rate of the universe. So we'll talk about those things. So I hope you enjoy this chapter.